why there is a need of NLP for Indian languages, why a lot of research is now being focused on regional languages as well, and what are the challenges if we start the work in this. Then I would be covering in the next section the tools and techniques. We'll be starting with the text processing techniques, that general text pre-processing techniques that are there in NLP, and what are the tools that for specifically designed for Indian languages. Then also I would be covering the pre-trained word embeddings that are there for these regional languages, and what are other pre-trained language models that are present for these languages. And after that, we can have a Q&A section as well. Okay, so yeah, so what is NLP? So NLP is basically natural language processing. That is the ability of a computer system to understand the human language in spoken or in a written form. So systems like chatbots or maybe speech recognition systems, like you all have seen nowadays, various conversational assistants like Alexa, Siri, are so common in our daily lives. Uh, you just open the phone, you just speak a query, and in back of the picture, there are a lot of algorithms running behind, and they can just answer your queries in a fraction of millisecond. So all these assistants, their backbone is these natural language processing algorithms. So, and this branch of artificial intelligence is basically utilized in creating those techniques. So there are a lot of techniques like machine translation, autocomplete, personalized recommendation, question answering, and spell checkers. So like in machine translation, so you have seen like there is a feature where you can translate from one language to other language. That also is comes under NLP bucket. Then there is autocomplete. Like you guys would have seen that whenever you type a query in Google, it will provide you some suggestions before even you complete your query. So that is kind of autocomplete. That is also powered by these NLP algorithms. Then whenever you visit a site like Medium or some other blog site, you will also get some recommendations of the blogs. So those personalized recommendations, a lot of text pre-processing, and NLP and NLU, basically the natural language processing and understanding, goes behind the picture of those recommendation engines as well. Then question and answering and spell checkers. Like for spell checkers, we all have might sometime use Grammarly or some other spell checkers. So those also used a lot of heavy NLP techniques. Uh, so so now this, but this all we have seen a lot of growth from the latest technologies in only in English, not in other languages. Like if still we see like some big players have done a lot of work in regional languages, but still if you go for languages like Punjabi or Bengali or some other which are spoken, which are currently termed as low resource, basically the data and the textual data and the resources, linguistic resources, are still very limited. In those systems we are still lagging a lot of behind to basically leverage these techniques. So why there is a need for uh, bolstering the research in these languages? So India have around 749 million internet users, according to some study in 2020. So I think 5 to 10% more would have grown till now. And it is known that only 10% of them are speaking primarily English. So the main language is English, and rest 90% primary languages like Hindi, Marathi, Kannada, Tamil, Telugu, and all. So if we see the map here also, there are more than 150 languages in India that are spoken by at least 10,000 people. So apart from English, there are a lot more languages that are there. And if a person from belonging from this language is not comfortable with English, so how he or she can go ahead and use this assistant and leverage the all the internet, all the resources that are there, maybe educational, maybe uh, some other social media resources and all those things. How would they be comfortable in using that? So to bridge that language barrier in this digital revolution, we need to focus on the regional languages as well. And as we know that 749 million internet users, it's not small, it's a large market. If we look according to the these company markets. So like let's ask some question to us even before starting. Like, can there be online platforms where users can post content in one language of their choice? Maybe someone comes and post a really great content in Bengali or say Tamil, but users from Punjab or Haryana wants to listen that. So can there be some social media or some online platforms where just speech to speech translation can happen, right? He's speaking in Marathi and we are listening in Tamil or whatsoever language, right? So can we build regional languages assistant as well? Like if we have those capabilities to work in these regional languages, we can even think beyond this Alexa and Siri to like these are somewhat kind of generic assistant, right? But we can think beyond those and can provide our small scale farmers or maybe small scale business owners the tools that they can communicate in their regional languages and get answers to a lot of questions. Maybe a businessman can go and ask about what raw materials or where are the markets he or she can get the raw materials. What are the various good ways or for a particular crop, what would be the uh, good fertilizers or whatever is there in it. They can just query and get the answers in a fraction of seconds, right? They can learn more about the market trends and uh, the products that they are trying to sell or they want to build. So these kind of systems can only be built when there are lot of good NLP resources for regional languages as well. So if I conclude here about this need section, so basically the Multilingual Society of India can only leverage and can overcome the language barriers and can like fulfill the dream of digital India when we focus on this regional language as well, not just English. So let's talk about the challenges now. So yeah, we have seen that there are a lot of languages, right? But why? There would be question that why the work was not done. So there are a lot more challenges if we compare to English. Like first of all, challenges is lack of data, whether it's annotated, like whether it's labeled, whether it's unlabeled, there is a huge crunch of data for these low resource languages. Like if we go just if we go to this Wikipedia, if we search for let's say Tamil, so we can see that. So basically, this is number of articles. So if you see for English or these top languages, it's like more than 65 lakhs, 27 lakhs. But when we go to Indian languages, for Tamil, it's like 150K. You can see for Hindi is still a lot more high resource if we compare to Tamil, but still there are 154K only for Hindi as well. So it's like very like it's like just 0.25% of the total articles, right? So it's very crunch of the data. Marathi, it's still below, like it's just 90K nearly. So this is the first uh, foremost challenge that is there for us, that there is a huge crunch of data if we want to have leave the task specific data sets. If we just want a generic data sets like just Wikipedia articles or just news articles, there is a huge crunch in these regional languages. And as we have known, like these systems like machine translation, question answering systems, or maybe some other spell checkers, these are like requiring a lot large amount of data. As we all know, in this data data rigorous models, the data is the main powerhouse for these systems. So we are lacking here. First of all, that's why it's a challenging task. Then second is there is a lot of there is a lot of lack in limit. So basically, there are limited number of open source tools as well. Like so in NLP, there are very various basic tools that are like very much frequently present in various toolkits like InLTK and Spacey for English languages or maybe some other top contributing languages in the world. But for Hindi, Marathi, Tamil, Telugu, Punjabi, these tools like parsers basically mean that when we have a sentence, we try to extract the syntactic info about that sentence. Then POS taggers is basically part of speech taggers, like what is the part of speech, and then named entity recognizers, like what are the entities in the in the text that is given to you. Maybe it's a place, maybe it's a person, maybe it's an organization, or maybe it's a date, maybe it's a time. Like a lot entities that we can define for our task also. So these tools are really important if you want to build a dialogue systems, or if you want to build some assistant system for regional languages. But due to limited numbers of these tools, uh, the progress is also kind of not so fast as that of in English. So so there is also a third challenge, is like there is also lack of proper standardization if we come to Indian languages. Like English languages, a lot of script standards like ASCII and other are there, but for Indian languages there are certain, but still they are not so much standardized. Like you can see for various spellings as well. Like when you go for chand, chand mean moon in English. So in Hindi, chand, chand have two variations. Maybe other word would have three or four variations as well. So these kind of spelling variations where this chandra is coming in one, and so in net, if you extract the data, you will find both of these. So when if you just blindly pass these kind of data or these kind of words to your model or the system, it will get unnecessary confused. Then there is also a lot of entities, like for these assistants, if you are building, let's say, a bot or something like that, and user is coming and playing that, play this cinema, or ye cinema chalao, or something like that, or maybe open this app, and you want to display in Hindi or some other language the text itself that yeah, this is playing, this cinema is being played or something like that. So we need to, if we want to display in Hindi or some other languages, we want this transliteration capabilities, basically changing the script. So even in those scenarios also we have a lot of ambiguity. Like cinema can be written as cinema or cinema. Same goes for app, ape, like ape, or with this Adachan app. So these are kind of challenges that comes with these languages. Like let's say there is a query, play Marathi songs on YouTube, right? So in Marathi, it's like YouTube वर Marathi गाणी play करा, right? But there is also variation, YouTube वर. Basically, this is like in Hindi, it is like YouTube पे Marathi गाणे play करो. So it's like YouTube वर. So in Marathi, this is like suffix problem. We term it as a suffix problem. Like suffix can be separate or suffix can be joined. It depends. Like some colloquial people will join it, but some, if you see, or some other literature or maybe some phrasal sets like news or something, they'll just separate it and give it the news. So getting data sets and then seeing like a lot of like not proper standardization is there among these kind of suffix as well. And these suffix issues are like a lot more common in Tamil, Telugu, Kannada. Like for this query as well, Karan, call Karan. So in Marathi, it would be like Karan la phone kara, but it could also be like Karan la phone kara. So let's say if you are evaluating a model, right? Like, so is it translating properly or not? So uh, let's say some linguistic gave you this one, Karan la phone kara, but your model is giving Karan la phone kara. So you're just evaluating like, is it accurate or not? And you are saying like, it's not accurate. But if you see that this was just a small suffix issue, and this is also making the same sense. So yeah, these kind of issues has to be addressed, otherwise you will unnecessary see performance drop that would be synthetic in your systems. Yeah, so there are also like various other challenges, like different dialects, like a lot, like even Punjabi language, Punjabi, uh, it has more than five dialects. Like I have noted the top five dialects, but it's like having more than five dialects. Like some of them are, and basically dialect means the language that is specific to some specific geographical part. Maybe like the Punjab region near to Pakistan, their Punjabi would be the people would be speaking slightly different to the regions which is like more closer to Himachal Pradesh or maybe some other regions, right? So like this Malvi, in Malvi, it is termed like it is said as Sadi life, like our life. In Punjabi, it's said as Sadi life. But in if you go in Maji, the same Punjabi would be like Hadi life. This will change. Same goes for Maji and Doabi difference, like second and third. It's basically in Hindi, it's Duja Tija is second and third. But like if you go Doabi, Doabi is the spoken near HP, the Punjabi spoken near Pahadi areas, basically. So it's like Duatia. So these kind of dialect difference itself will make the building of these kind of NLP system for regional languages challenging. Then there is also very common challenge, which is termed as code mixing, mixing of two or more language varieties in speech or text. It's kind of very common in our nowadays chat language, right? Like if we chat with some our personal friends or family, also we generally tend to use these English queries. But let's say you want to, so one of the system wants to understand it or maybe correct the spellings, like how to go in that direction as well. Like because let's say if you have a model for English, you just can't use it for English. Like you are writing in Roman language, maybe system detects it's a Roman, but if you read it, it's like aaj ki latest news sunao. So latest news is in are basically English entities, but these are basically Hindi entities, right? Or maybe some song like Jida Tumari Bollywood which entry. So Bollywood entry are English, but this is like kind of Punjabi words written in Roman. So these kind of data points are also somewhat challenging if they come into the system. Okay, so let's go with the tools now. Like what? So we have seen the challenges, we have seen what is the need, but now let's how to use the tool, how to use the tools that are present in Indian languages. So basically for text pre-processing, so let me explain text pre-processing in one or two line first. So text pre-processing is basically transforming the text into clean and more compatible format before even passing through these ML models or systems. You just can't pass the raw text, whether it's training, whether it's inference time. You have to pre-process the text, make it more clear, make it more clean, make it more standardized format. So this that step is basically known as text pre-processing. So it contains a lot of techniques like tokenization, basically splitting the tokens or splitting the words, removing punctuation. In some of the task we might need punctuation, in some we might not, so removing punctuation, segmenting the sentences. Stemming is basically stemming the word into its like primary form, basically running, stem it in, it will stem it into run. So these kind of processing are there. And text pre-processing, there can be task specific pre-processing as well. Like these, some of these are general, but there could be task specific. Like let's say you are building a model that wants to predict user sentiments, like what user is want, like what are the intents or what are the sentiments behind this uh, utterance that user is saying. So you might think that I might not remove the emojis, because emojis will also tell whether user is happy or your user is sad, right? But let's say you are building a spell checker, you just want to correct the spelling in uh, whatever user is writing, right? So then it doesn't make to even consume the emojis. So you can create your preprocessor, you can just remove the emojis as well. So these kind of pre-processing techniques varies according to the task also that you are performing. Then for Indian languages, there is a toolkit that is named as InDic which is a Python library which provides common text pre-processing techniques for Indian languages. So it's like supported for more than 10 Indian languages. So this is the link. So basically, it's like released by AI for Bharat. It's AI for Bharat. Uh, so you can go and see this link Indic NLP and see a lot more like a lot of these text pre-processing functionalities are there for Indian languages, and you can see like this is Sanskrit, Hindi, Urdu, Punjabi, Nepali, and all these languages. So you can see what all tasks you can perform for what all languages. And so what we can do is we can just quickly go ahead and so I have just written a notebook like how to use this. So I'll share the resources after this webinar, but like just to rerun it. So let's just clear the output and restart. So what you can do is that basically run pip install indic NLP library in your Python environment. Then you have to download these two resources basically, and download these two resources and just uh, define the paths of these two folders before starting. Then you just have to initialize and load these paths and initialize the library. Then let's see how we can just text normalize, how we can use the text normalization facility of this library, right? So basically normalization is removing the randomness or noise in the text. So basically those Chand type of things, right? Like Chand was having a Chandra Bindu and other was having Chand and Bindu. So those things of like, sorry, just the Bindu. So those things of basically so basically standardizing those kind of variations that we have. So you just have to import the normalizer object here, just create an object, then just pass the language code here. Then you can, there are various parameters as well. So here we are passing that you should remove the Nukta and you should also remove, normalize the Chandra. So we'll see what is Nukta and Chandra. So let's say this. So Kagas de do. This is Kagas de do. Let me zoom it a bit. Okay, yeah. So kagas de do. So this z sound that is basically borrowed from Urdu in Hindi. So this j ke niche wala dot is basically nukta. So so these also like simple kagaj will also work somewhere. So you will have multiple variations. So you want to normalize into one. So what you so when we pass from this normalizer object, it will just normalize it. Kagaj de do. Then the other normalization it is doing is this is basically this is Poon Viram, full stop in Hindi. Like Poon Viram is ending the sentence, but this is pipe character of the keyboard basically, which is like with the slash, right? So this is pipe character. So this won't be like you will see a lot of text, Hindi text, where people have made mistake and added this pipe character rather than this Poon Viram. So this is very common mistake in the textual data. So we see that it's also normalized right now. Then we see about this Chandra wala thing also. So Chand kahan hai? So these were Chandra Bindu. These are now normalized in without the Chandra. So at least we would be having more standardized words now. Now similar, if we see for Punjabi as well, what we have to just change is basically just change the language code. So you can go to that link I was referring before and just see the language codes as well for the languages. So PA is for Punjabi, right? So remove nuktas and do normalize chandras is true. Then for Punjabi, there is some additional features available, like do canonicalize tippi or adak. So tippi and adak are also some of the matras that create issues, not issues, but basically variations of words. So if we see this, so this is a Punjabi word amb. Amb means basically mango. So this is called tippi, the above part. So the basically this ulta chant type of symbol. So this is also more. So we have normalized this So maybe your data would be having this also, this also. So what you have done is you have normalized this also in this, so that basically the same word mango, that is amb in Punjabi, won't be having too much variations now. Similarly, it goes with Akh. Akh is basically Akh. It's also removing this. So this is basically Adak. This was Tippi, and this is Adak. So it's also now normalized. So basically, this is also a second variation that is present. So this will be remaining same, and this one will be converted into this. So you have less number of now variations. So yeah, so you can use this tool, just like it would be a good practice, like just to normalize the data sets before even you try to think to even analyze some data or not, right? Maybe you are trying to see what are different n-grams or what are different tokens present, or maybe you are just trying to make a dictionary out of your data. So if you normalize before this, then you will have more proper analysis, because now these unnecessary variations and noises would be removed. So for more language support, you can go to this link. This is the script that they have provided. So you can see that for Tamil, there would be a different normalizer. You can see like what all normalization they have. You can just go through the code and see what all normalization is provided. Like for Punjabi, there is this Gurumukhi normalizer, this one. So here I have seen that, yeah, Chandras, and other than Chandras, this um, this is Gujarati, sorry. So yeah, Punjabi is this. So other than Chandra, Adak and Tippi and all those are also provided. So whichever language you are working on, you can just go through this normalizer once before using them. Then let's see some other pre-processing tools as well. So splitting of text into tokens. So basically, this is a simple technique, right? Like in English, also we have seen that we just need to split the words from a sentence, from a given sentence, right? But the point, the catch here is that if you use an English tokenizer, it won't tokenize this Poon Viram, right? So that's why, or maybe some other punctuation that might be specific to that specific language in India, right? So this tool will take care of that as well. So we have seen that it's tokenize ha and the Poon Viram separately. So these issues can be handled by this tool as well. Now, there are a lot of use cases where it would be needed that maybe there are certain entities that you want to display in the similar, like you don't want to translate them, the movie names or the songs. Like in Hindi also you will say, then you will say only that Dilli Che Lagao or something like that, right? Like, or maybe Hey Baby Lagao in Hindi as well. With Hey Baby is the English word, but because those are entities, you won't want to translate them. You just want to change the scripts. So you can use this um, Unicode Transliterate as well, right? So this you just have to pass like import this class Unicode Transliterator. Just use this transliterate function, and you can just convert the script like this case area. So basically, this is for Indian to Indian language only. For English to Indian, we'll see next, but this is for Indian to Indian. So for from Hindi, we have converted the script into GU and Punjabi. Let's say you have a movie name that were written in Hindi, but you want to build some model that for Gujarati as well, like that displays the name in Gujarati, right? So you can just use these converters to create your own data sets, right? So this is Kesaria in Gujarati, this is Kesaria in Punjabi. Same goes for the Dilli Chhe. So you can use this in Gujarati, and then this is in Tamil, right? Now, let's say you want to convert the Roman script into Indian script, right? So like this, Gaane Bajao, you can use this ITransTranslateReturn. So basically, this content is transliterated into Devanagari. Basically, Hindi is like Devanagari script. It's converted into Gaane Bajao Devanagari. If you go into Gujarati, so this is like kind of Gujarati movie, a common Gujarati movie. I think so. It's now converted into the Gujarati script. So like I'm just showing word by word, but you can run these into a lot of larger data sets. You just need to know what all these tools are basically doing and how they are working. So then there is also use case like when you pre-process your data, you might be having a lot of paragraphs, not proper sentences, structured sentences, right? So you might need to split those sentences, paragraphs into sentences as well. So this splitter can also be used for Indian languages. Same goes like for Poon Viram, it has seen that it's Poon Viram. So it has split it because it's Hindi, right? So Poon Viram is the full stop. So that's why it has split it. This number of sentences we can see come as 4. So there are also this word segmenter. So basically, word segmenter is like the issue that we were seeing, right? That so words are basically the morphs, basically the units of those languages, right? So if you use this for Marathi, let's say, so these suffix are different words, but they are basically used with the in the sentence like this only. But this morphessor is able to differentiate between the name and the suffix also, right? So while evaluating or while post processing also, you can use this analyzers to see what all different words and not just making ambiguity between joining and separating. You can have a single standard to separate and use this morphessor for that. So yeah, these are some of the tools that I had just explored through. So you can go ahead and see that link of NLP, and there are a lot more other tools as well. The translation support is also there, and some other phonetic information capturing and all those things are also there. A lot of things are there, so you can just go ahead and it's very like easy to use. It's very friendly, so you can just go ahead and play with this or maybe play with these as well, so that whenever you start with a project of Indian languages, you can just use directly these normalizers or other preprocessors. Okay, so now let's go to the other important aspect of NLP, that is pre-trained word embeddings. So basically, like, so not to go in too much detail of ML models here because that would be an out of scope, but like ML model is basically a mathematical function, right? So the text can't be passed just directly, right? So we want some mathematical representation as well for the words or maybe for the characters or maybe for the subwords, like whatever, however you define your token, right? So word embedding is basically used to represent these words, typically in a format of real value vectors. And those vectors are in such form that they encode the meaning of the word. So that similar words tends to be closer. If we have a three-dimensional vector, right? And we represent these words. So we see that king should be more closer to queen than uh, uh, woman, basically, right? Or in other words, we can say that this is very classical example to explain these embeddings, word to vec embeddings and glove embeddings. So basically, this is called relational similarity. Like A is to B, then what is A star is then what is A star is to. So basically, a man is to woman. So basically, king would be is to queen. So how this is defined is like basically you can say that man minus woman would be equal to king minus queen, basically. Uh, so basically, if you add this man minus woman thing into king, right? So the difference here should give the queen. So the closest to this should be the queen, right? So it is showing this like A star minus of A minus B, basically. If we take this bracket, then the closest should be B star, and that B star should be queen. Same goes for this. Like if walking is to walked, then swimming should be to swam. So these kind of basically word meanings are being captured by these representations. So these representations, and these are generated by training on a large amount of data. And those data are basically general, not much task specific. So like if you have a task, you can just use these embeddings rather to train those representations, because there might be cases where you don't have much data to get proper embeddings as well, right? So you can just load these embeddings and then fine tune these embeddings on your task. So there is also a good tool that you guys can explore and use, like if you are using some of this embedding word to vec and you just want to understand. So this is embedding projector. So this is by TensorFlow. So what you can use here is like you can just load the embeddings. You can load your own embeddings also if you have, or you can just see what all embeddings they provide. So the default is word to vec and 10K words are there. So right now it's like three-dimensional. So what we can do is we can just search for a word. Let's say songs. Okay. So we search for a word songs. So it is showing the most basically nearest words to the songs. So you can just see, right? Like the farther one are way different from songs, right? The constitute doesn't make, but which are like closer ones are songs, movie, dance, love. These are the top closest one. So it's like kind of three-dimensional, so you might not be seeing that these are too close, but if you like in high dimension, these are very close because these are mostly close, right? Or maybe you can just isolate these points and now see songs, lyrics is too close, right? Tunes is too close, sound is too close, dance is too close, but composer, text, poetry is still a little bit far, right? So this visualizer is basically to check the, so you might be having some use cases where you train your own embeddings, right? So you can use these embedding projectors and just see the quality of the embedding, just eyeball through your text sentences or maybe words and see like, does these words are closer, that should be closer or not. So that will give you a high level idea of how your embeddings are there. Or maybe you can just load some pre-trained embedding before even starting a task and see, like let's say there would be some embeddings that would be capturing some other things than just the meaning, and you require that. So you can just load the embeddings in this platform and see that the closest words or the closest tokens that are coming to a particular token, is that only that you need for the task or is there something else. So like personally I've seen this tool to be very very much helpful in analyzing these embeddings and making a decision like which embeddings I should use for a particular task. So you can just load also. There is a feature from loading from your computer. So you can load this. So there is a specific format that you need to just read and follow. But after that, it's like simple like this only. So you can just load your embeddings and visualize and analyze. So, okay. So let's see what all embedding options are there for Indian languages as well, right? So, there is a fast text name library that is also a Python library, which has provided pre-trained word embeddings, and it was created by Facebook AI. So the models were trained with the basically language model task only. So language model is basically predicting the next word, like predicting the next word given the previous words. So let's say I am running. So if you give a model I, then it should be able to predict am. Then if you give a model I am, it should be predict running. Like these kind of next word prediction kind of task. This language models is basically trained like that. So this is basically what how these are trained are basically they have extracted the embedding layers here, right? So they are here also like they have just used character engrams, and these character engrams have vectors associated with them. So for each character vector, they'll just sum it over the word to get the word vector, right? So this is also available like for 294 languages. So you can go to this page and just download for like let's say Hindi. So you can just download it for Hindi or Gujarati. So this 294 languages contains Indian languages as well. So you can use this. So we can see a small code snippet also how to use this as well. So let me restart this kernel also. Okay. So first of all, you have to load that uh, load the models or load the vectors from that path, and then you can just have those path added to the directory that you are working in, right? So then you can just load these models. Let's say for Hindi, if I load this, right, and then if I just for word nritya is basically dance, right? So uh, yeah. So 300 dimension embeddings are there. Maybe you can just reduce the dimensions according to your use case. And then if we see the most similar words here in this embedding, it's like nritya, nrityagan, nritya geet, nrityo, nrityat, nritya kala, nritak. So most of this related words are nritya. So I think as they have saying that they are working like they are like taking the character information. So mostly the nearest character is nritya only to all the nearest words, right? So it shows how these embeddings are being trained. Same if you see for Kale, right? For Kale also, like Kale is everywhere. It's not that something like volleyball came, but it's like after 8 9 words, right? So so most of the top words are like and you see like this, maybe their data was not normalized also. Kale with Poon Viram is coming here. If you can use, like before training your embedding, if you can use the normalizers or maybe the word tokenizers, basically, sorry, not normalizer, the tokenizer, and tokenize the word properly. Maybe they might have used a tokenizer which don't know the Poon Viram, right? But if you use a Indian language specific tokenizer, it would have known this Poon Viram. And this Kale and Kale would have been a same word only. So that's why we can see that this Indian language specific tokenizers and segmenters are important. Then I have downloaded the same thing for Gujarati also to check. Uh, so that was also working fine. Like you can just load the Gujarati model, see the embeddings, and then you can see what all nearest words are coming. So these embeddings are basic building blocks whenever you try to build some classifiers for textual data. So you can, so preferably what generally it's done is that these open source embeddings are used, and then they are basically maybe or maybe not fine tuned or just used statically in your modeling approach, so that whatever knowledge these embeddings have, you can just use as it is, and then put your task knowledge on top of it. So this is fast text. Then there is also a similar library called InLTK. So it is also open source library. It also provide various pre-trained language models, sentence embeddings for Indian languages. So these embeddings are also trained on some language model task also only. And then it also provides sentence embedding. Like right now we were just seeing the word embeddings, right? The representation for words. So this toolkit also provide to get the representation for the sentence as well. So one naive way that always is used to get a sentence representation is just sum the word embeddings of present in that sentence, or maybe average out the embeddings that is present in the sentence. But sometimes it is seen that just averaging or just summing loses a lot of context, and the positional information is also lost, right, in such kind of techniques. That why they create the sentence embedding, like they extract the sentence embedding from the encoder, so that that context and the position information sort of is kind of saved here as well. So yeah, these are obtained from encoder output, so these are kind of contextualized in nature. uh, so we can just quickly go through this also, like how to load this. So I haven't downloaded this model, but I think I was reading this, like I've used this. So this is also very simple to use. So it's like from you just have to import this embedding function, and then you can just code up this language. So basically you can see how to set up. The setup is also very 2-3 line setup is there, and then you just have to do this setup function for code of language. You can get the code from here. So it supports code mix also, the code mix scenario that we have seen, English. So code mix is very limited, but yeah, I think the most common is this one, English one. So it support that also. So if you are performing on a task which has English queries, then you should go with these kind of embeddings. So you can just import this and then get embedding vectors by this function. Just add the code of the language, and then it provides 400 dimensional vectors. You can just see, and then you can maybe create a function and see what all similar, or maybe you can just download these embeddings and upload in the format that TensorFlow projector is required, and just can visualize these embeddings as well and see like are these embeddings uh, would be working well according to your task or not. So that is there. Then the pre-trained models, right? So these embeddings that we have seen are somewhat kind of static embeddings, mostly like word to vec, glove. These are kind of static embeddings. Static in the sense that they are once trained and then they are just used as it is, and then they lose the context. Like if I use the word embedding of Kale in one sentence, like ये खेल कैसा है, or maybe मैं खेल रहा हूँ, So if I use word-to-vec embedding, those are not contextual. So the Kale would be having similar representations, though the representations and the meaning of words changes according to their context, right? So for those kind of scenarios where we need more kind of contextual embeddings, or maybe the nature of the task isn't such that the position and the context of the words also matter, so we go with these kind of pre-trained models that are available right now. Mostly these are kind of models that are trained on general purpose language understanding tasks, and they are like trained on a lot large text data sets. Like we can see there are a lot models like Google's BERT, OpenAI's GPT, Microsoft, Facebook's Robota. So we can see the parameters as well. So it was like the first GPT is here less than like around 1.110 million parameters. Sorry, the image is not clear, but yeah. So BERT large was like 340 million. Then like we have seen the recent trend that these kind of models, the number of parameters is increasing exponentially. Like the recently that the GPT-3 that was released, like the chat GPT, basically it was like having around 175 billion parameters. So these kind of models are trained on a lot more data, so you can use these models directly for your task. These embeddings are really helpful to for I think most of the NLP tasks, and these are kind of contextual as we have seen, right? V- a word will be having different embedding according to its context, so you can directly get the sentence embeddings as well. These so mostly these models like recent nowadays these models are basically taken and fine-tuned for NLP tasks. Like let's say you want to uh, build a model that wants to detect the sentiment behind the user, so you won't be like creating your own model. You can just maybe take a BERT and just add on basically a small layer on top of the BERT and then just train it. That technique, basically using these kind of openly available pre-trained models to the downstream NLP task, is termed as transfer learning. Like this is very common term, so uh, people might have heard of this as well. So yeah, but the thing is that the same thing like we have seen, but most of these are in for not specific for Indian languages, right? Like they would be having their multilingual variants, but still those multilingual variants would be like what's it won't be performing too well, that is expected, right, for Indian languages if we compare to some other high resource languages, right? So what are the options for Indian languages if we want to use transfer learning for our task? So, two of the main that are like recently used are, one is Mural, second is InDigBird. So, Mural is basically multilingual representation. It is a bird standard bird based architecture, that is basically 12 layer architecture. It was released by Google, and it was like trained on 17 Indian languages, no other language. So it is specifically for Indian languages. So let's say you want to build a sentiment classification or spell checker for Indian language, right? So rather than going with multilingual BERT or simple English BERT or some other multilingual language model that is openly present, you can also use this one because this is more specifically Indian. And the training strategies here include the translation and transliteration segment pairs as well. Basically, transliteration, English to Hindi, those kind of transliteration entities were also present in the training data. So those kind of code mixing scenarios and all those things, these kind of model will be more helpful than a general multilingual model. So yeah, so we can just quickly go through that. So you can go through this doc as well. They have provided a good doc. So these are the languages that are being supported by this model. Then they clearly show that so there these are some of the standard tasks. So Panax and this is basically NER task. So you can see a lot of improvement is there, like if you use a general multilingual BERT or if you use specifically for Indian languages. So for each language we are seeing like they have shown that it is improving, right? for similarly, these guys have shown that XNLI, and this is XNLI is basically a sentence classification task. Like for a sentence, there would be like a particular class. Then these X squad, this Tabiotoa is this is basically a information retrieval task. Like you can go ahead and read about these tasks as well. These are very standard tasks in NLP, this extreme benchmark. But like just to show that this model performs really well. So like this X squad, MLQA, these are basically question and answering tasks. Like for a given question, answer, like provide the answer. So here also specifically for Indian languages, if you have a use case, you guys should go ahead, because like I think uh, this model, those guys have trained taking a lot amount of Indian language data. So we can also see loading this model and getting the embeddings is also very simple. So sorry, this one, yeah. So loading Mural. So this is the link. Like Hugging Face is a library that provides a lot of these pre-trained open source models and the interface to like download it very quickly. So you can just give the path. So this is basically name. So it will directly download from internet. So it might take a minute. Then you can just load the transformers library. You can just load these functions, auto model and auto tokenizer. So basically auto tokenizer will load the tokenizer from this path, and auto model will load the model. And this auto means basically it will detect, like in the config, it will detect what model architecture is that, and according to that only it will load. So I think it was in my cache, so it got loaded. Then कोई अच्छी सी film लगाओ. This is a sentence. Let's see how we can get the embeddings for this sentence as well. So right. So we just first of all we tokenize it. So tokenize it will. So these models are basically not on word level. They tokenize on subword level. Basically, subword is just more granular unit than words. So like koi achhi si film lagao. So there are various techniques like byte pair encoding and all those things. We don't need to go right now on that, but there are various techniques to get these subwords. If interested, you guys can read about that. But yeah. So in basically before even tokenizing, these two tokens are being added in a general these kind of transformer based networks, right? So one is class CLS for classification, and then this one is separator. Like if you add a more sentence, you can use this separator, right? So these two are loaded, and then you can see that after tokenizing, you just have to extract the hidden states of the model. So as it was like kind of 12 layer model, and one layer is before the 12 layer, that would be embedding layer. So fully 13 layers model. And then these are like 8, right? Sorry, 9, 0, 1, 2, 3, 4, 5, 6. Yeah, 8, sorry, yeah. So these are 8. So yeah, this dimension is basically the number of tokens, and this is the hidden dimension. The dimension of the each token has the 768 dimensional embedding, and a total of 13 layers are there. So if you want to use these representations in any of the tasks, what you can just do is that um, you can just either use this. So basically, generally, not to go in architecture, but this CLS token representation would be having the representation of all the content that is there in the sentence. So generally, if someone wants to use a classification task on these kind of representation, what you can do is just select the last layer, like this. Just select the last layer output, and then that too of this one. Use this representation after passing the sentence, and just build a classifier or very small MLP classifier on top of it, and you can get good results on any classification task, right? And these embeddings, as I say, are contextual in nature, according, because this will having the full context of all the sentence, right? And then if you want specifically word embedding, so here we can get the token embedding that are mostly subwords. So let's say this will give the word embeddings. But let's say if you see laga and o, so you can combine these tokens to, like, you can just like you can just combine those subwords in the post processing step, and then for lagao also you can just average over these lagao and get a average representation. That would be the contextual word embedding of the contextual word embedding of this word. So yeah, I think, yeah. So these are also very like simple to use. Like Hugging Face provide a lot of pre-trained models. Like for InDigBert also, you can just go ahead and see there would be InDigBert. So what you have to do is just in the same code, you just have to change this path, and so auto tokenizer model will automatically detect and just run this same thing, and you can get the embeddings for that model as well. So it's like very user friendly to use. So yeah, so InDigBert is also kind of BERT based architecture, but it's like kind of LBERT based. So LBERT is also a variation of the BERT model, but it's like kind of a lighter one basically. So it's like much simpler than BERT. And they have trained on these 12 Indian languages. So if your use case is this, then you can also try to use this. So basically, generally, the approach is that you try 2, 3 models, right, and see like which is performing better, or maybe according to your requirements, like whether you want to, uh, whether your infrastructure can support complex model, or you want some lighter models and all those things. So according to those needs also, not just the numbers, according to those needs also, one can go ahead and choose one of this model, or maybe evaluate on all these and then choose according to the performance as well. So yeah, other than these two, pre-trained models, one can also explore anytime this multilingual models. So these are MBERT, XLM, and XLMR. So these are present in Hugging Face and open. Like these are also open source, but just these are not specific to Indian languages. So, but it's no harm to give a try with these models as well if you want to like build a model for languages other than English. So yeah, I think with that, I feel now people will have more sense of the tools that are available, and what all would be challenges if one try to build a model in like these kind of models in Indian languages. So mostly, yeah, I am done with my content.
So before we proceed to answer your questions, I would like to request the attendees to please fill in the poll about feedback as it helps us to conduct more such sessions. Thanks a lot, Karan. On behalf of Analytics Vidya, I would like to thank you for your time and delivering such a wonderful session. I am sure your attendance found it insightful, and hopefully we can conduct more such sessions with you in future. If you have any questions, please put it in Q&A. So can you see the Q&A session?
Yeah, just a second. Polyglot for multilingual autocomplete and what are packages used? Autocomplete and spell checker, what are packages used? So let's go with this question first. Just a second. Autocomplete and spell checker. So I feel for autocomplete and spell checkers, there are not open source packages present. So you have to build the models, but before building the models, you can use these pre-trained models like Mural and InDigBert, and you can just form a task of autocomplete, like an encoder decoder or something like that. Same for spell checker, and train a model on top of it. What kind of problem is Flipkart solving using NLP? So yeah, for NLP, there are a lot of problems in Flipkart, it's a e-commerce, right? So people will be posting a lot of reviews, right? So we need to see like are those reviews moderated enough to be posted or not. So before even posting, we need to check the there is no unnecessary or spoofy language used or something like that. Other is Flipkart also have chatbots, maybe pre-purchase and post-purchase. So in those chatbots, also a lot of NLP is used to understand the user queries, to give the answer to give the answers to the users, or maybe give them the status of the deliveries and all. So those problems and other problems as well, like these kind of spell checkers, or maybe providing the autocomplete uh, uh, autocomplete, or maybe providing the chats in the other language as well, right? Like Flipkart is highly used in tier 2 cities as well. So providing language support for other than English, like Hindi, Marathi, and all those languages, the chat options or the search options to users. So that is also some of the problems. Then how you how you are projecting it in 3D. Okay, so I believe this is like in that TensorFlow one, right? So let's open this one. So there is there you can see 1 second. You can see there is component 3. So if you close it, it would be a 2D. If you just select it, then you can just project it into a 3D. Then that's one. Is there any application or web page to see? Is there any application or web page to see the usage of this NLP tools for to see the usage of the NLP tools for Indian languages? So if you mean the contribution or the usage, how much of the tool is used, I don't have like knowledge about the web page, but like how to use and how to use, you can just go ahead in the official documentation. Like whatever tool I have talked about have official documentation. You can just go ahead and check that. Mhm. Is there any tool for semantic role labeling for Telugu language? Semantic role labeling. So I think Indic NLP or AI for Bharat should have a tool for Telugu as well. You can check that. Some pre-trained models should be there, but I think for specifically for role labeling, they shouldn't be there. So you can just see like what uh, 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 model you can use and build a role labeling for Telugu. Mm, Will you suggest any course or learning material for NLP? I think there are a lot of courses, but if you just want to get started with NLP, there is a book from Jurafsky. It's like I have just given a reference. 1 second. So this one, the fourth one. So this is a really good book to get started with NLP. Like it starts from basic and then it goes to even deep learning and machine learning, word vectors, everything it goes through. So this is very good book. You can download the free version, the PDF from here. So I think that would be a good start. And then I think there might be some online courses for NLP as well in Coursera. You can look for that as well. I think this company one we can skip. My resume, it is. It still has scope. Your suggestion and direction as most of the tasks achieve accuracy. Your suggestion and direction as research and embedding still has a scope. Your suggestions and direction as most of the task achieves around 75%. Yeah, so the thing is that research and embeddings definitely have a scope because these tasks are still very standard tasks, right? Like they have defined it and they have tuned the model so well. But when live user data would be coming, right, in companies or maybe anywhere, like you just take live Indian, like whatever people are speaking, like colloquial languages, how people are speaking, right? If you apply those things, apply those use cases, these embeddings won't perform much better. You have to do more, maybe noise cleaning, maybe standardizing, or maybe training, making your models more robust to such kind of noises as well. So accuracy of 75% on this standard task is okay, but like, let's say on these kind of noisy environments or colloquial languages, the performance will be less. So there is a lot more scope than that is visible. Yeah, I think it's enough. Or is there anything
Yes,
else?
so you can stop.
Yeah, yeah.
Thanks a lot, sir. On behalf of Analytics Vidya, I would like to thank you for your time and for delivering such a wonderful session.
Okay.
I
Thank you,
hope
everyone. Thank you, everyone, for attending.
I hope you guys have filled the feedback poll. If not, I request you to please fill it. The feedback poll helps us to conduct more such sessions. We'll be back with another session of Data Hour on 8th of January. The link is in the chat section. Till then, bye bye and keep learning.